We are the lake owner, and our lake have a lot of bawal fish. We have a task. We want to know what is the average weight of all of our bawal fish. Do we have a way to find what is that one number to represent the average? We have 4 ways. The first one is a very fast way. Catch 0 bawal fish, just make a guess, and we'll say that, oh, the average weight of all my 1000 bawal fish is 540 grams. This is not so scientific. The second way is just to catch 1 bawal fish, weigh it, and we'll say that, oh, just now I weighed my bawal fish is 720 grams. So the average weight of all my bawal fish is supposed to be 720 grams. It's not so convincing, right? The third way might be the better way to catch all 1000 bawal fish. Then use the average formula, the mean formula, to find what is the weight, what is the average weight of all 1000 bawal fish. After add all 1000 bawal fish weight, divide by 1000, the average is 763 grams. 5 days spending, so tiring. Or is there a better way? Yes, we just catch 10 bawal fish and then use this estimation procedure for the mean to find what is the possible range of our population weight bawal fish. We can have a very high confidence level saying that with 95% confidence, the bawal fish average weight might be somewhere between 506 gram to 770 gram. Catch 10 bawal fish may cost just 1 hour compared to the C1, 5 days. Which one we prefer? This is chapter 8, estimation procedures. We're going to look at 2 examples. We're going to look at 2 cases. The first case when we have population standard deviation. The second case when we don't have population standard deviation. Let us look at the first case. We have. Jerry wants to help the lake owner to estimate the average weight of thousands bawal fish in the lake. He wants to make an estimation. That is to find the range. The population standard deviation is given 90 gram. So we have population standard deviation. Using the 95% confidence level, find the range of the population mean weight of the bawal fish from this lake. We have 10 sample weight as below. We catch 10 bawal fish. This is the data that we have. Starting from the first bawal fish is 570 grams. The last one is 440 grams. This is our task because we want to help the owner to estimate the average weight of 1000 bawal fish. We want to find what is the average weight of all bawal fish. We cannot get the exact number. However, with 95% confidence, we can have the range. Means that most likely the average weight of all the bawal fish, by just spending 1 hour to find it, by just catching 10 bawal fish, is between this number to that number. Okay, for this case, because we have the population standard deviation here given, so the formula that we want to find the error margin is this formula. The error margin equals to the Z critical times the population standard deviation divided by the ZN. We're going to follow 4 big steps to get the conclusion. The first step is, what do I want? The second step is, what do I have? What information, what numbers, and what formula that I have. The third one, combine these formula numbers, how to solve. And the last one, what will be the conclusion? Let's look at the first one. So the first one is Jerry wants to help the lake owner to estimate the average weight of the 1000 bawal fish, and he don't want to catch all bawal fish. He just catch 10 bawal fish, and he has no choice but to use the estimation procedure to find the range. He cannot give the owner one number. So he's going to give the owner the range. Step number 2, what do I have? So based on the information here, we have the first one is the population standard deviation, And then the sample average is we get from the 10 bawa fish average. Add them up. First fish weight plus second fish weight plus third fish weight divided by 10. This is the average of 10 bawa fish, 562. The sample size n equals to 10. This is 10 bawa fish. Now the formula that we want to use is to find the E, the margin of error. The formula as stated here. Why we use this formula? Because we have the population standard deviation. So E later on will be inserted into the range of minimum and the range of the maximum. X bar is the sample average. So the critical and difficult is to find what is the E, the number. How to solve it? So for this case, we want to find the E. E is equals to the ZC, the Z-score critical value, times the population standard deviation, divided by the cert n. We have three elements here. The difficult one is to find what is the ZC here, the Z-score critical value. We have two ways to find what is the ZC. One is the slow way, one is the fast way. Slow way is a bit finding it from the Z table itself. We need to identify what is the probability, the percentage. Then we reflect it to the Z number here. So because we have the 5% based on the 95%, we have the balance 5%. So the 5% will consist of the two tails, the left and the right. Means that the left will consist of 2.5% and the right side is 2.5%. Means at the end, our probability based on the table here, we need to refer 0.975 probability number to reflect to the Z number there. So what we get is here. It's so small, I will write it, it is 1.9 here. The first column and the row reflect 0.6, so 1.96. This is the ZC. Faster way is to use the confidence level table for the Z case. So 95% is 1.96. Immediately we get the number. So we replace ZC equals to 1.96 into the formula and we'll get the E equals to 55.78 gram. This is our E. So we're going to put the E into the range formula here. So we're going to get the range of our possible population mean weight is between 506 until 617 gram. So we want to write the conclusion now. So now we're going to write the conclusion. The general way to state the range is we are 95% confident that the true population mean will lie between these two numbers here. For our case, we are 95% confident that the true average weight of all our bawa fish in the lake will be between 506 gram to 167 gram. Can we do something about these two numbers here? Yes. One day, let's say somebody, a businessman, approach us and say that, oh, I want to rent your lake, I want to catch all your bawa fish and then I'm going to sell the bawa fish on the market. Then we think about, okay, the bawa fish price is 40 ringgit per kilo. What is the price that I can offer to the businessman? So if we know all the average weight, if we know the average weight of all our bawa fish, then we can easily say that, oh, the average weight of all my 1,000 bawa fish is this number, times 1,000 times Rm 40 ringgit. This is the price. For our case, since we know that the lowest possible average weight of all our bawa fish is 506, so we take 506 gram times 1,000 bawa fish times 40 ringgit per kilogram. So we can sell all our 1,000 bawa fish to him at 20,248 ringgit. If we use the maximum population average weight, so we can sell at 24,700 ringgit. This is the case when we know our population standard deviation. How about when we don't know our population standard deviation? For this case, we don't have this information here. Jerry wants to help again the lake owner to estimate the average weight of 1,000 bawal fish in the lake using the 95% confidence interval. We want to find what is the range of the average weight of bawal fish. So again, he catch 10 bawal fish. This is his mission, to find what is the minimum and the maximum number to represent the possible population average weight. We don't have the population standard deviation, so this is the formula that we're going to use. Not much different. The difference is we're going to, instead of use the ZC, Z critical, we're going to use the T student critical number, and then we're going to use the sample standard deviation. This, we have the formula. Following the 4 big step here, what do I want? The first one is, I want to find what is the minimum average weight and the maximum average weight. Step number 2, what do I have? Okay, the red color means that we don't have the population standard deviation. However, we need to find what is our sample average based on 10 fish data here. The third one, we want to find what is our sample standard deviation. Why we need to find? Because later on, S is appear in the E formula here, error margin formula here. To find the sample standard deviation, it takes some time because we need to construct a table for us. If we do it manually, first to find what is the summation of the X minus X bar, and to find, at the end, to find what is one S number. Sample size, N equals to 10. And then we're going to use this formula to find the error margin of the error. E equals to the TC times S divided by the N here. So later on, we're going to plug inside E into the range formula here to find what is the maximum and the minimum value of the average weight. Step number 3, how to solve. Okay, everything is easy in the formula here except for the TC. How to find the TC? We have no choice but to use the T table. For this case, we're going to use true tail. Why? Because 95% here, 95% is referring to the center 95%. So we have left and right two tails. Total of the two tail is 5%. So we're going to select this column here. Okay. Now we want to match it to the which row? Which row? It depends on the DF. DF equals to degree of the freedom equals to n minus 1. We have 10 data minus 1. Our degree of freedom is 9. So degree of freedom is 9 is at this row, and then we're going to see what is the intercept number, 2.262. This is the TC. So replace TC into the formula here. Then we're going to get E equals to 1 to 1.43. Replace E into the range formula. So our minimum weight of the average is 440 gram and the maximum is 683 gram. Now we want to write a conclusion. We still need to say something at the end. We are 95% confident that the true average weight of all my bawal fish in the lake will be between 440 gram to 683 grams. Again, if a businessman comes and he says that he wants to buy all our bawal fish here, we can negotiate price based on our minimum average weight. 1000 times 440 times 40 ringgit per kilogram, that is 17,600. Or if we want to earn more, we can say that, oh, the highest average weight of my bawal fish is 683 grams. So we can sell at 27,300. Now we're going to look at 4 tutorials. The first tutorial question is the dean of the university, he wants to use the mean of the random sample to estimate the average amount of time student to walk from one class to another class. She wants to exert the probability 0.95 and her error will be at most 0.25 minutes. If she knows from the past study that the population standard deviation is 15 minutes, how large a sample she will need? So for this case, since we know that there is the data about population standard deviation, so we're going to use this formula. We are not going to use the unknown formula. Following the 4-bit step, what do I want? Okay. At the end, how large a sample she need? How many students that she need to survey? At the end, we want to know what is the sample size. We want to know what is the n. Step number 2, what do I have? So let's look at the information here. We have the population standard deviation given 15 minutes. The sample average, no, we don't have any information. We don't have the data too. We don't have the first student is 17 minutes, second student is 20 minutes. No, we don't have. Sample size, this is what we are looking for. Margin of error is 0.25 minutes. The dean, he wants to have control the error at 0.25 minutes. So we have the E equals to 0.25. So confidence interval formula, it seems that this is not where we're going to use it today. How to solve? For this case, is a bit different compared to the Jerry case. For this case, we want to find what is our n here. We want to find what is our n here. This is not related. So we're going to plug everything inside and see whether we can at the end find the n. So do we have the E? Yes, we have the E. The error margin is 0.25. Do we have the ZC? Yes, we have ZC because the dean says that 95% confidence level. So ZC is 1.96. Do we have the n? No, we don't have the n. This is what we want to find. Do we have the population standard deviation? Yes, we have population standard deviation is given as 15 minutes. So at the end, you're going to form this formula to find what is the value of n. After calculation, the n that we got obtained is 13829.76 because students cannot be point something. We need to make it into a integer, a number. So at the end, n equals to 13,830 students required to do the survey. Okay, this is tutorial 8.1. Let's look at tutorial 8.2. Okay, tutorial 8.2, a study was carried out to find the mean height of 15 years old student in SMK Jeli, Sekolah Menengah Kebangsaan Jeli. A random sample of 100 students was selected. So we know that n equals to 100 now. Previous study says that the population variance of the height of student is 80 cm. Be careful. It's a tricky question because it doesn't say about the population standard deviation. Population variance, however, relates to the population standard deviation by STATISTIK. Suppose the sample mean weight was 145 cm. Oh, now we have the sample mean 145. Find with a 95 confidence interval for the mean height of all 15-year students in the school here. For this case, we have the population variance related to the population standard deviation. So again, we're going to use this formula. We are not going to use another formula here. Step number 1, what do I want? At the end, I want to find what is the minimum height and the maximum height of the students. Step number 2, what do I have? I have the the variance, population variance. To find the population standard deviation, we just set the variance. So at the end, we get 8.94. We also been given what is the average sample weight, sample height here, 145 cm. We are given the total of the n number here. The formula we're going to use this one because sigma is known. Step number 3, how to solve. So for this case, it will be direct because at the end we want to find what is value of our E, and then we're going to plug the E into the range formula here. Okay, to find the E, we need to find the set critical value. For this case is 95% confidence interval. So from the confidence interval table here, 95% is 1.96. This is the population standard deviation. We have it, 8.94. Cert N, total 100 students. Now we have the value of our E. So at the end, E equals to 1.7531. We replace into the range formula. So we get the average minimum height of the SMK jelly student is between 143 cm to 146.7 cm. When we write the conclusion, we say that we are 95% confidence that the true population mean of 15 years old student in SMK jelly height will lies between 143.25 cm to 146.75 cm. Most likely that this is the true population mean. Tutorial 8.3. The mean weight of 8 adults as given below: 70 grams, 70 kilograms, 72 kilograms, and the last one is 78 kilograms. Construct a 90% confidence interval. Estimate the mean weight for all the adult males. This problem, we don't have the population standard deviation. So we're going to use the unknown, the sigma unknown. Step number 1, what do I want? At the end, I want the range. What is the minimum weight and what is the maximum weight to represent the population mean of the adults? Okay, what will we have? We have the sample average. Okay, sample average is add all these 8 kilograms divided by 8. And then sample standard deviation. Okay, using the formula, we get 5.15. Sample size is 8 males. This is the formula to represent the error margin. How to solve? Okay, the critical one is to find what is the value of the TC. The T critical, it depends on first one. 2 tails, 90%. It is 10% or 0.1. Now we want to intersect with what degree of freedom. Degree of freedoms equals to n minus 1 equals to 8 minus 1 equals to 7. So it matches with the 7. The TC equals to 1.895. 895. Okay. So we plug all the known elements into the formula here, the E formula, so we can find what is our range maximum and the minimum. We're going to write the conclusion. We are 90% confidence that the true population mean of adult male weight will lies between 69.55 kilograms and 76.45 kilograms. Last tutorial 8.4. The length of 12 fishes caught from a lake is given as below: 9.8 kilograms, 9.1 kilograms, and the 12 fish is 10.5 kilograms. Assume that the population follows a normal distribution with a variance of 4 cm. Again, it's not given the standard deviation, it's given the variance, and based on the question, it sounds like this is a population. Population 1. Okay. Calculate the 99% confidence interval to estimate the true mean length for all fishes in that lake. Okay, for this problem, since we can make a good guess that this is a population standard deviation given, we're going to choose the green color. Means that we're going to use this formula. Step number 1, what do I want? So at the end, I want to find what is the range of the weight, the minimum weight, maximum weight that will say about the population weight. What do I have? I have the population standard deviation. Even though we are given the population variance, however, we know that just set the population variance, we're going to get the population standard deviation. So it is 2. And sample average, we get it from the total, the cm, divided by 12. We get 10.025. Sample size n equals 12. We're going to use the margin of error formula. This one because the green color. We know what is our population standard deviation. To find the confidence interval, we're going to use this range formula here. How to solve? To solve it, we're going to use the error of margin equals to ZC divided by the population standard deviation divided by the ZN. So the difficult again is to find what is the value of the ZC, the Z critical, when the confidence level is 99%. So we are not going to pick the 95%. We're going to find what is the 99% here later on. So we're going to plug all the numbers into the formula here. So we put this box here. So we have the population standard deviation 2 divided by the ZN 12 times the Z critical when confidence level is 0.99. So at the end, our E equals to 1.4896. Place the E into the margin formula here. So place into the confidence interval formula there. So we're going to get the range of the cm to represent the population mean of their length is 8.53 cm to 11.51 cm. So we can write the conclusion as the below here. We are 99% confident that the true population length of our fish in the lake lies between these two numbers. Okay, that's all for our topic. They estimate the procedure. So at the end, even though we don't have the population mean, we can use this estimation procedure to find what is the range of possible our population mean. Okay, thank you. Details check at the eCampus.